There are two types of addressing schemes in networking: classful addressing and classless addressing. We discuss both of them, although we use only the classless addressing nowadays. Classful addressing. Here, the address space is logically divided into 5 classes: A, B, C, D, and E. Each class occupies some part of the address space. We can find the class of an address that is given in any form. If the address is given in binary notation, the first few bits can tell us the class of the address. If the first bit of the first byte is 0, then it is called as Class A address. If it is 10, 110, 1110, and 1111, then it is a Class B, Class C, Class D, and Class E respectively. If the address is given in decimal dotted notation, the first byte defines the class. If the first decimal number of the first byte is in between 0 to 127, then it is a Class A address. If it is in between 128 to 191, 192 to 223, 224 to 239 and 240 to 255, then they are Class B, Class C, Class D and Class E respectively. One problem with classful addressing is that each class is divided into a fixed number of blocks, with each block having a fixed size. There are two parts in any IP address: the network part and the host part. The network part is used to identify network, and the host part is used to specify number of supported hosts. The network portion has the same value for all hosts on a single network, such as an Ethernet LAN. Class A addresses. In Class A addressing, the first 8 bits of the IP addresses are used for the network ID. And the final 24 bits are used for the host ID. For example, take 10.1.26.2. The first 8 bits or the first octet, that is, 10, is the network portion, and the next 24 bits, that is, 1.26.2 is the host portion. As one bit in Class A addressing, 0, is reserved for class identification, it can assist 2 power 7, 128 networks, and 2 power 24, 16,777,216 hosts. These 128 networks are called number of blocks, and 16,777,216 hosts is called block size. Class B addresses. In Class B addressing, the first 16 bits of the IP addresses are used for the network ID. And the final 16 bits are for the host ID. For example, take 172.17.125.210. The first 2 octets, that is, 172.17, represents the network portion, and the next 2 octets, that is, 125.210, is the host portion. So, Class B addressing can assist 2 power 14, 16,384 networks, as 2 bits are reserved for class identification, 10, and 2 power 16, 65,536 hosts. Class C addresses. In Class C addressing, the first 24 bits of the IP addresses are used for the network ID. The final 8 bits are for the host ID. The same applies for the Class C addressing. So, Class C addressing can assist 2 power 21, 2,097,152 networks, as 3 bits are reserved for class identification, 110, and 2 power 8, 256 hosts. Class D addresses. These addresses are reserved for multicasting. The first 4 bits of first octet are always set to 1110, and the remaining 28 bits represents hosts. IP address range for Class D addressing is Class E addresses. These addresses are reserved for research purposes ranging from 240.0.0.0 to 255.255.255.254. The first 4 bits of first octet are always set to 1111. There are various reserved IP addresses for special purposes, and for private networks. Reserved IP addresses for private network. These are used by routers outside our home network, and not used by the general public. Network address translation in the routers translate private to public IP address. These public addresses will be used by our mobile phones and PCs or any other end devices. The range of private addresses for Class A is, for Class B is, and for Class C is. Special IP addresses. The range between this address to this address is called link local addresses. The range between this to this address is called loopback addresses. And the range between this address to this is used to communicate within the current network. The classful addressing has a huge flaw in it. The Class A format provides a small number of possible network IDs and a huge number of possible host IDs for each network. That is, it provides 128 networks and a huge number of hosts, which is practically not useful for almost any organization. Class B also is very large for the organizations. And the Class C, Class D and Class E are too small for any organization. So, in classful addressing, a large part of the available addresses were wasted. Subnet mask for classful addressing. The length of the network ID and host ID is predetermined in classful addressing. So, we can use a default mask, a 32-bit number, made of contiguous ones followed by contiguous zeros to find the net ID and the host ID. For example, the mask for a Class A address has 8 ones, which defines the net ID, the next 24 bits define the host ID. It can be logical ANDed with the IP address to extract only the network portion. The concept does not apply to classes D and E. The last column here shows the mask in the form /n, where n can be 8, 16, or 24, in classful addressing. This notation is also called slash notation or classless interdomain routing (CIDR) notation. When the network mask is specified as a prefix, for example /16, then that number of bits is the size of the network part, and the remainder, out of 32 for IPv4, and 128 for IPv6, is the host part.